Hello, and welcome back to yet another retro channel. Today we're going to be taking a look at machine number 5. Now this machine is a little different. This is a 250425 board, meaning it has these simplified clock generation circuitry and uses the 8701 clock generator chip. The problem with that, from my perspective, is that this is the only 425 board I have, so I don't have a working machine to test that 8701 in. What we're going to have to do is test all of our other chips, make sure they're working, or replace any that are bad, repopulate this board, and then try the 8701. And if that doesn't work, try a replacement 8701. So we'll get to that in a little bit, but we just need to go ahead and take care of our basics first. Now, again, in this instance, I have already replaced the power switch in the board to save time. I have already cleaned the power jack, so hopefully everything there is going to be working. But our first step here is to go ahead and test our voltages again, or retest our voltages. Go ahead and plug in our power, make sure it's turned on, and get our probes and go for a little probing. So I'm going to pick up ground and then check the right pins on both of the voltage regulators. This is the 5-volt regulator, 5.04, that's a good value. This is the 12-volt regulator, 11.96, that's a good value. Now we can go ahead and test our 5 volts from the power supply by going to pin 6 of the CPU socket. And I get pin 6, 1, 2, 3, 4, 5, 6. Oh, there we go. 4.98. That's good. To go as far away as we can, I think it goes this way. Check at the user port, 4.98. And one final check for voltage. We need to check the AC voltage on the other side of the user port, 10.61. So all of our voltages look very good. We can go ahead and switch off. The next thing we need to do is check all of our chips in the ZIF machine. Now this computer, we're at a big advantage here. So this could be a very quick repair because all of the major ICs are socketed. Even one of the logic ICs is socketed, but I don't think I have that one socketed on the ZIF machine, so we'll have to test that in the Mini Pro. So let's get the ZIF machine up on the bench. I'll get it connected to video, connected to power, and we're going to switch over to the output, see if everything is working as it is. We should get a screen. There we go. Okay, so that's working. Now we will one by one go through and check our other ICs. Let me add, there we go. Now that may make the output screen jittery. I need a faster capture computer. What happens is when I try to do an HDMI capture, if I try to capture anything else at the same time, the HDMI capture stutters. And that can be seen both in the video and heard in the audio. There we go. Standard dead test. I've lost track of what bank I put the STID dead test in, but there is dead test running with the ZIF machine. So we can begin to go ahead and swap out chips. The first chip we should obviously try is the CPU. So let's see if the CPU from our 250425 is working. And yes, it does seem to be. So we'll let it run through here. Okay, so we have a good CPU. We'll give that a tick mark. Next, I will check the PLA. There we go. And do we get a working machine? Yes, we do. So we'll let that run through. Okay, that's a good PLA. So we'll give it a tick mark. Next, we will check the VIC2. This is an R8 VIC2, so if it's working, it'll give us a pretty good picture. And it's working. We'll let this run through again. All right. So we have a good VIC2. Now those three, the VIC2, the CPU, and the PLA are the only three, plus the clock generator, 8701 chip. Those chips are the ones that I'll need to get the other machine at least running dead test now. So let's go ahead and look beyond those and try out the CIAs. So try the first CIA. We will want to watch the clocks at the bottom of the dead test, assuming dead test comes up. Okay, we're getting AM and PM with synchronized times, so it looks like the time of day clock in this CIA is working. We're not going to be able to tell anything else because apart from that, the dead test does not actually use the CIA. All we can tell is that it's not trashing any of the buses and that the time of day clocks are working. So that's all we can test with the CIA in the dead test. So we will mark that as good, or actually we will mark that with a dot because we think it's good, but we haven't fully tested it yet. And then we'll do the same thing with the second CIA. We might have a... No, thought we had a bent pen. It wasn't sitting down in there quite correctly. There we go. So here we go with the second CIA. Okay, again, we're not trashing either the data or address bus. So let's wait for the clocks. And again, we're getting synchronized 14 seconds AM and 14 seconds PM. So that CIA, like the other one, is working as far as the dead test can tell. So that's good. Next, I'm going to check the kernel ROM. That is 227. Again, the dead test can only tell, it doesn't actually use the ROM. All it can do is tell if the ROM is going to trash the address or data bus. And it's not. So we can consider that at least partially working. Now we'll pull the basic ROM and test out 226. Okay. Checking the basic ROM. Okay, again, we're not clobbering the data or address bus, so we've got an at least potentially working basic ROM. And now the character generator ROM. Oh dear. Okay. Do we get any bus conflicts? Nope. So again, a potentially good character generator. And last but not least is the SID. And again, we have an R4AR SID, so I'm hoping that that works. Okay. So we'll have to let the test run all the way through for this to hear if the SID runs, or see if the sound test passes. Well, it's not trashing the bus. That's good. Ooh, one little glitch. Well, that's going to warrant more testing once we have it in the other machine. I'm going to mark that with a question mark. All right. So that is all the testing we can do with the ZIF machine. Back to the board. Start repopulating things. The 258 goes here. Okay. Big 2. Oh, I'm forgetting something. All right. Now we can put chips back. Okay, the big 2. So we're going to leave this SID out for now. CPU. Okay, PLA. That's all we need, apart from the 8701, to get dead test running. However, I'm going to say this. Our original inspection of this machine showed no signal at all, which implies to me that since the VIC is working, the PLA is working, the CPU is working, the most likely culprit is this 8701. So we will try it with the original 8701, but I'm thinking we're going to have to replace that. So let's give this a shot and see what we get. Still no signal. Okay, so let's try a replacement 8701. Now, I did get these from AliExpress, so they could be as fake as they come. I don't know for sure, but we're going to give it a shot. I think Adrian from Adrian's Digital Basement used some 8701s from AliExpress, and they were fine. So hopefully we're going to luck out here. Okay, there's our new 8701, and let's see if we get anything this time. And will you look at that? We're getting a signal. It's not a good one. We got black screen this time. It's interesting. Same thing again. Let's try a different 8701 from that batch. See if maybe it's just a little wonky. Okay, there's another 8701. Same thing. Okay, so there is something else wrong with this board, and I'm not sure what it is. Okay. Something else I noticed when I was inspecting this board is that a lot of these logic ICs have been either replaced or reworked, and the soldering job on them is really bad. So what I'm going to do is I'm going to reflow all these chips. Now the main ICs, as far as I can tell, have not been tampered with. They still look like they have the original factory solder. These logic ICs are kind of a mess. The RAM looks original. These two are also logic ICs, and they look like they've been redone as well. So let me go ahead and reflow all of these chips to make sure we've got good connections, and we'll see where we get from there. I just retouched all these 4, these 3, these 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 logic chips that I just reflowed the solder on to try to make sure they were well connected. And I'm still not sure about looking at these two. Back to the overhead view. Looking at these two, there are still some pads where it doesn't look like the solder's flowed all the way through, so I'm not 100% certain there. But let's see if that improved anything. Again, we're on the dead test cartridge. Looks like we're still getting nothing. So, okay, time to probe some of the rudimentary signals and see where we are. So we're going to check reset on the CPU. Oh, reset is low. That's not good. Okay. If the CPU is being held in reset, then we need to look at the timer circuit, the 556. So this is the 556 timer, and it's pin 9 that's output goes to the reset vector, reset pin on the CPU. So that pin is never going high. So, is there a problem? The 556 timer. Well, again, this is one of the ones that I touched up the solder job on the bottom, but a lot of those aren't flowing through to the top. So what I'm going to do is I'm going to pull that, put a socket in, and try replacing it. Let's see if that does anything for us. Okay, let's see if by any chance we just had a bad solder joint in there. Let's clean this up a bit. Okay. All right, turn off the extractor fan. And video. Let's see if we get anything now. Still a black screen. And are we still getting... Yep, still stuck low. Okay, so let's swap out the 556 for a new one. Brand new, never soldered 556 timer. Okay. Any improvement? No improvement. So it wasn't the timer itself. It is something else in the timer circuit. What do we have in the timer circuit? Let's see. I should have plus 5 volts on pins 10 and 14. So 10 is not 5 volts. What? I'm not getting 5 volts anywhere. Well, helps if I turn it on. Okay. Still not getting 5 volts. That's not great. Why am I not getting 5 volts? I was getting 5 volts. No volts. Turn it on. 5 volts. And 10 here. 5 volts. Okay. 10 and 14 should be 5 volts. They are. Why does that smell? Something just fried itself on this board. I can smell it. We lost our 12 volts. So, how many of you caught my screw up? Can't believe I did this. I am not used to working on the 425 boards or the 469s or any of those. where things have changed. And I plugged the PLA, a good working PLA, into U17, or into U18 rather. This is the SID socket. This is U17, the PLA socket. On these boards, they've swapped places, and I forgot all about it. So I killed the good working PLA, which is a tragedy. I killed my GAL PLA. Not quite as big a tragedy because all I really need to do is program 2 new GAL chips. But when I put in the PLA from the ZIF machine, and boot it up, we get the dead test. Oh boy. That was just stupid of me. Again, I keep creating my own problems that I then have to go fix. My bad. This time I cost myself a chip. Well, several chips. But we know the 8701 is working, the VIC-2 is working, the CPU is working, and once I program a couple more gals for this gal PLA, we'll put that back in. So let's move on to putting in the rest of the tested ICs. Okay. Okay, we're going to still leave this sit out. And we are going to switch. We're going to switch over to the regular diagnostics, or actually this will be the updated diagnostics, the 586220 with an asterisk, and see what we get. Ooh, black screen. So something isn't happy. Make sure I've seated all the chips properly, and I think I have. Back the dead test. Okay, dead test still works, so logically it's going to be one of the ROMs, and try kernel first. One of my replacement kernels. Try it without the cartridge, that'll be the quickest. And there it is. Okay, pop in the dead test, or not the dead test, the diagnostic ROM again. So off, on, off, on, RAM low rather. Diagnostics. Running, good. All right, so let's get out the test harness. Okay, we're going to let this run through with the test harness installed. I am not going to put the SID back yet. We're going to try without it first. So we should see a fail on the 6581 and on the control ports. All right. Everything but the SID. Now let's try the SID. Well, it's not clobbering the bus. That's a full pass. That's great news. Okay. So, one last thing to do. This keyboard needs work, but okay, that'll do it for this machine. It's just too bad I was an idiot. So I'll need to do a complete refurb on this keyboard, obviously. And what did this end up being? So, the only original problems were the 8701 was bad. Then, I put the PLA in the wrong socket, so I blew up the PLA. I also blew up the gals on my gal PLA. We removed and socketed the 556 timer, but that may not have been a problem after all. I can go ahead and I actually should try that. Pop the new timer I put in back out. Okay, there is the original 556 timer. And do we get basic? We do indeed. So the 556 timer was fine. So that can go back into stores. So, not the most expensive, not as expensive as it could have been. Oh, and we also had the kernel ROM. So it could have been worse, but it could have been better if I hadn't been an idiot. These two chips were genuinely bad, the 8701 and the kernel ROM. These I destroyed by being a moron. That'll do it for machine number 5. I will go ahead and create or burn a couple of gal PLAs since I destroyed these and put it in place of the PLA from the ZIF machine. That will do it for this episode. So if you liked the episode, give it a thumbs up. If you didn't, hey, you know what to do there too. I'm willing to take criticism as quickly as I'll take compliments. So do whatever you need to do there. And go ahead and share the video. Please share the video out to as many people as you can. The more views I get, the better. Leave a comment. I love the interaction with my viewers. I really don't know if I'd still be, I'm only been doing this a short time, but I'm really not sure I'd still be doing it if it weren't for the engagement with you guys. You keep me going. You keep me wanting to come back for more. So I really appreciate it when you comment, and you can, in this case, you can comment all you want about how stupid I was and how you saw what I did right up front, and and you'll be right about all of it. Subscribe to the channel if you haven't. Ring the notification bell so you get notified when I post new videos. And be sure to check out my YouTube Retro Repairers group, other members. That's Joseph Retro Bits, Retro for You, Captain Commodore, and 8-Bit Retro Refix. I will put their contact or their channel information in the comments below. Also, please keep in mind, at the end of this month, the last Sunday of the month, those folks I just mentioned and I will be doing a live stream where we'll be chatting about what we've got going on, what we've seen in the retro world recently, all kinds of issues, and we will also take questions and comments from the audience. We did this last month, and I will link to the video for that if you didn't get to attend. I'll link to that in the description below. But we're doing it again the last Sunday of this month, and that will be 2:30 p.m. Eastern Time, United States, or 7:30 p.m. Greenwich Time. The last one lasted something like an hour and a half or 2 hours, so you can plan your day around joining us. That being said, we're going to wrap this up for the day. I know normally I would say that I was going to go ahead and modify the RF modulator to clean up the video, but this is a different version of the RF modulator, and frankly, I don't know what needs to be done to clean up the video in here. It's a much simpler circuit than the one that we work on the 250407 boards, so that won't be something that I'll be doing. I will be heat sinking and, like I said, making a replacement for the PLA, and then get the keyboard and the case refurbished, and this thing will be ready to go. So I hope you enjoyed. I enjoyed my time with you. We'll see you next time. In the meantime, be safe, be well, and have a great week. Bye.